And here is the drawing. It is drawn in Simul IDE version 0.4.15-SR10. And guys, Simul IDE is not just for drawing, but it is a simulator for Arduino and other electronic components. And these are the people behind this great work. It is created by Santiago Gonzalez, and if you want to become a patron, just visit this site. Alright. So what we have here is a power supply that will supply the stepper motor's driver. And the drivers N1, 2, 3, and 4 here will be connected to Arduino's pin 8, 9, 10, and 11. While your power supply will receive power independently, it just needs 7 to 12 volts, or you can use a 9-volt battery for this one, or converter that is not above 12 volts. This stepper motor should be connected to this socket of the driver, and you won't get lost in connecting the stepper motor because it comes with a female socket that will rightly fit here. The home button or the limit switch is connected to pin 4, and the other pin of a normally open button will be connected to the ground. So you do not need to connect it with resistor because it will be using an internal resistor of the Arduino, and your Arduino here will go to the computer. Alright guys, I think that's all about for this circuit, and let's go to our sketch now. Here is the sketch of this project, and let us have quick explanation of the codes. And the first code is including the library, and that is the stepper.h. This one here is the type of the stepper 28BYG-48, and this is part of the kit, which you can have a total steps in one revolution of 2048, and I call it SPR, or steps per revolution, and declared it as an integer, or you can do this as constant int. Stepper, my stepper, is an object. Do not change the order of these parameters here. SPR 8, 10, 9, and 11. Otherwise, the stepper will not work. I already tried changing this one, and yes, the stepper will not rotate as it is already programmed in this order from the library. The maximum speed you could make for this type of stepper is 10. And that is in revolution per minute. This is the direction, and you will know later how to make clockwise and anti-clockwise direction of the stepper. The home button. I am using a tactile button to simulate the limit switch, and also you can use a magnetic Hall effect sensor instead of having a mechanical switch that will use to stop the stepper. This is homing, which is equals to the digital read of the home button. And aside from our library, I am individually declaring pin stepper 8, 9, 10, and 11, which were connected in the Arduino's 8, 9, 10, and 11 pins. These ones here are coming from the driver of the stepper. The void setup. Pin stepper 8, 9, 10, and 11 are outputs. Pin mode home button is an input pull-up, which means you do not need to connect it with the external resistor. And guys, if you want to make a zero position or a reference position of the stepper, it must be done in the void setup. And so therefore, we must have to rotate our stepper in the void setup. And my stepper, that set speed, stepper speed. When the Arduino is initialized, the stepper will rotate in the speed of 10 RPM. And we need to read the limit switch. Homing equals digital read home button. And here it is when the limit switch is not touched, or the magnetic Hall effect sensor is not sensing a magnet, or when the tactile button is not pressed. Homing equals to 1. My stepper, that step rotate times -1. and our stepper will rotate in an anti-clockwise direction in the speed of 10 RPM. And this is anti-clockwise facing the shaft, but when it is used to drive a valve, the valve will rotate in a clockwise direction in closing direction. So our valve or the stepper will go to a zero position when the valve is fully closed. If this is not in the while loop, the valve will keeps on rotating in this direction and it will damage the motor, it will damage the valve before it will be stopped. And with this in the while loop, you could get out when the home button is pressed, and you will proceed to the next phase, which is the pen stepper 8, 9, 10, and 11 will become low, and therefore no more pulses will be generated and the steps of the stepper will be stopped. So guys, I still don't have in the void loop, but my next project is incrementing each step or counting the steps of the stepper. So please watch it and let us upload this one. Then uploading, and let us see the circuit. And guys, I hope you learned something, and please subscribe.